A very good evening to Dr. Liu. My name is Shahirah Binti Sabana and I'm going to present my answer to question number 5. So the question that I got, the student made his research question. So his research question is whether the body height of student related to the states, and the data that he provided is the all of the students are UMS female students. He also provided the student identity for each one of them, and then their body heights, and then their state of origin. So there are 3 states involved here, which is Sabah, Sarawak, and Terengganu. And as you can see, the research questions is not complete. It is missing some important terms, and then I have to modify it. And even the data is unorganized, so I have to organize it in a table and then make a graph. Moving on to the modified research question. So the research question, is there any significant difference in body height in meter between UMS female students from Sabah, Sarawak, and Terengganu? Moving on to the experimental design. The response variables here is the body height in meter. The experimental unit is the UMS female students. The treatment is the state, and then the level for each treatment is there are 3 of them, which is Sabah, Sarawak, and Terengganu. And then the replicates are 18 UMS female students because the total respondents are 18 UMS female students. The sampling, the population is UMS female students from Sabah, Sarawak, and Terengganu. And then 6 students are selected from each state, making a total of 18 students. Moving on to the data organization. So I organized the data in a table with 3 columns. And as you can see, the first column is the student ID. The second column is their state of origin, which is Sabah, Sarawak, and Terengganu. And then the last column is the body height in meter, their body height in meter. So I arranged them according to their state, so it is easier for me to see. Moving on to the data organization, and I made a box plot entitled The Difference in Body Height in Meter of UMS Female Students from Sabah, Sarawak, and Terengganu. As you can see the difference in this box plot. For Sabah, it has an odd outlier, and then for Sarawak and Terengganu, they didn't have any outliers. And how I make the box plot from R. So moving on to R. Of course, the first thing that you have to do is set the working directory. So this is the command to set the working directory. Just type set wd open bracket double apostrophe sign, and then just copy the file address on where you store the data that you first collected, and then you do it in Excel. Then you save it as CSV, save it in a file, and then from the file you can access here. And just copy the address. So the file name is state height q5, so I just have to find state height q5, and then just copy this one file address and then just paste it here at this sign. Make sure the sign is in pairs, and then you can just click run, and then that will set the working directory. This here will show that you are in the right working directory. And then you have to log in the data. So the data, you have to give the data an object name. So I name it as state height, and then you just have to do this sign, this arrow sign, and then read read.csv, open bracket, double apostrophe sign, and then just copy the name of the file, state height q5. This one, just copy the name and don't forget to add the .csv, and just click run. Once you click run, you will find here this one, the state height, and just check it here. Make sure it is the same as the one that you made in Excel earlier. Make sure it is the same, even the spelling, make sure it is the same to avoid any mistake. And then Moving on, you have to read the data frame. So in order to read the data frame, you just have to type str open bracket and just the new object name that you set earlier. Then just click run. And if you click run, you can see this one, the data frame. And as you can see, these two are supposed to be factor. For ANOVA, it's supposed to be factor. You're supposed to change it into factor. So this is the command to change the factor from CHR to factor. Just type the name of the object and then $sign, and then the first the one that you wanna, the factor that you wanna change from CHR. So I did the student ID first, the arrow sign, as dot factor, and then just repeat the same one as this one. But this one is in bracket, means that you want to represent this one as a factor name as this one. So it doesn't matter if it is the same name. And then moving on to the second one, the state, because the state is also in CHR, not a factor. So just do the same thing, the name, the $sign, and then just change it into state. The arrow sign as dot factor and open bracket, just do the same thing as this, just copy this one, and you can just click run. And if you click run, it doesn't like show this one, but you have to click this one. You just have to check the data frame again, and you click run. You can see that the CHR is changed into factor. So this is the correct data frame. Then you can just proceed to the box plot, making the box plot, and then just for the Shapiro test, normality test, and the statistical test that you wanna choose. And then I move on to box plot. As you can see, the box plot, you just have to type box plot, open bracket, the name of the object, $sign, the variables that the measurement according to, and then the name, $sign, and then the state, which is the category. And you can just click run. But if you want to change the title or the y-axis and the x-axis, you can change it here. So want to change the title, just type main equal apostrophe sign, and it's just type any title that you want, and then comma. This is for the y-axis. You can just type y lab equal open for double apostrophe sign, and then just type any title you want. The same goes for the x-axis. Then moving on, after you made the box plot, oh, you can just save it. Here is the box plot. Once you click run, you click run from here, just click run. I can see this box plot here. You can just export it, save as image. You can change the height, the width, and etc. You can just save it, and then you can just represent it here. Moving on to the assumption test. So as usual, there are two assumption tests. In order to find the statistical test, you have to perform these two tests, which is the normality test and the test for homogeneity of variance. For the normality test, for both of them, you just have to make in R. So in R, you can for normality test first, you have to make a subset. So there are three levels of treatment in this experiment. So the first one is Sabah, Sarawak, and Terengganu. And then you have to make a subset for each of the state in order to test the normality test. And then just do this one. Just name the object, the treatment. For me, I just put Sabah. The arrow sign, subset, open bracket, the name, comma. This one is the program. Program means the one that you choose from. Like if it is a class, then just class, double equal sign, and then double apostrophe sign. Just choose any class that you want. It's according to your data, and that is the command to make the subset. And this you just repeat it for Sarawak and Terengganu. And once you click run, you can find it here. So it's separated. So for Sabah is something like this, Sarawak like this, and then Terengganu like this. And then you can just proceed to the Shapiro test. Shapiro test is the test that you can make for the normality test. For the normality test, you can just type Shapiro.test, the first subset, which is Sabah, and then the measurement variable. And then the same goes for any other state involved. You can just click run, you can see the result here. So you can see the p-value for each of the state. For Sabah is 0.5235, for Sarawak is 0.3536, and for Terengganu is 0.7046. Therefore, the p-value is larger than 0.05. So we can say that it accepts the null hypothesis that stated that the data for this experiment is normally distributed. And moving on to the test for homogeneity of variance, you just have to type the library and search for the car package. Click run. You can just proceed to the live-in test. Live-in test is the test that you can make uh, for the test for homogeneity of variance. You can just type live-in test. Make sure it is the right spelling, and then the name of the object, $sign, the measurement according to name, and then the category. Just click run. And if you click run, you can see this is the result here. And as you can see, the p-value is 0.8331. Therefore, it is larger than the critical value, which is 0.05. So the variance between samples are equal. So these experiments accepts is normally distributed, and the variance between samples are equal. So the statistical test that was chosen should be a parametric test. So the one that I chose for this experiment is one-way ANOVA. Because the data is normally distributed, the variance between samples are equal, the variables are independent of each other, and there are 3 treatments for the state of origin. Thus, the most suitable statistical test for this experiment is one-way ANOVA. We proceed to the statistical hypothesis. So the null hypothesis for this experiment is there is no significant difference in body height in meter between UMS female students from Sabah, Sarawak, and Terengganu. And the alternative hypothesis is there is a significant difference in body height in meter between UMS female students from Sabah, Sarawak, and Terengganu. And we set the criteria at alpha 0.05. So we just proceed to the statistical test. So statistical test for the ANOVA, one-way ANOVA, we can make it in R. So the first thing that we have to do in R is we just type AOV, open bracket, the name of the object, the $sign, and then the measurement according to the name of the object, $sign, and then the category, which is state. Just click run. And if you click run, you can see this one. This is the result for the click run. You can see this is not showing any result for the p-value. So in order to find another output result that we can see, we save the we save the uh, we save the this one AOV as a result. So we save it as one way. Just copy this one. Here you can see it is the same one as this one. Just copy and then make summary and then one way. Then you can see this is the result. And as you can see, the p-value is larger than 0.05. So the p-value here is 0.739. Therefore, the p-value is obviously larger than the alpha, which is 0.05. So we accept the H null that stated before here that there is no significant difference in body height in meter between UMS female students from Sabah, Sarawak, and Terengganu. So to conclude, the one-way ANOVA statistical test result showed that there is no significant difference in body height in meter between UMS female students from Sabah, Sarawak, and Terengganu, as the p-value is larger than the critical value, which is 0.05. And that's all. Thank you.